Welcome to the deep dive. We take your sources, we dig in, and we give you that strategic shortcut. Today, we're tackling something huge, really complex. This massive problem of perishable food waste in retail. It's always been there. And you shared some really fascinating sources. They show how this old fight might finally be turning, not because of, better managers, but smarter tech. We're going deep on AI, predictive analytics, blockchain. They're all kind of working together to change the game for supply chains.
Yeah, it really is more than just efficiency. It's a whole new way of thinking, isn't it? For so long, it's been reactive. You wait till things get close to the date, then you scramble. So our mission today really is to unpack how these technologies offer actual solutions, moving the whole system from just like reacting to problems to predicting and neutralizing them before they even happen. We want you to walk away really understanding this shift in inventory management. It's about sustainability, sure, but also about efficiency and, frankly, profit.
Okay, let's unpack that. Starting with prediction. That seems fundamental. The core thing AI is solving here isn't just knowing something's about to expire, right? It's predicting spoilage before it happens based on the product's actual real-time experience.
That's exactly the distinction. We're moving away from just looking at that static date stamped on the package. We're looking at the product's real journey.
Yeah.
Its life experience, you could say. And this is where machine condition prediction, or MCP, comes in. It's a really critical piece.
Okay, MCP, how does it track that life experience?
Well, MCP works by using this huge network of real-time sensors. All across the cold chain, we're talking temperature, humidity inside the container, maybe even vibration data stuff that indicates rough handling. All this data builds up a really precise kind of individual biography for that specific item or, pallet. The MCP algorithm uses this biography to spot items that have a much higher risk of going unsold, often days before their official expiry date.
So it's not just the date. It's detecting maybe a tiny temperature spike 2 days ago, something that might have cut the freshness of, say, strawberries in half.
Precisely. That little blip in temperature, something a human manager might totally miss or never record. That's the exact data point that triggers an MCP alert. And this predictive ability lets retailers take action before the food is lost. What's really striking is the impact. Studies show this specific kind of prediction can cut waste from premature spoilage by up to 20%.
20%, wow.
Yeah, that's a huge amount of product saved just by knowing its true condition, not just its printed date.
That is impressive, really tightening things up. But MCP sounds very micro level, like the single item or a small batch. How do retailers handle the bigger picture, the flow of goods across a whole region? Because waste isn't always just one bad pallet, right? It can be systemic.
Right, that's where we move from MCP to broader predictive analytics. That operates more at the macro level. These are really sophisticated models. They're built to forecast future spoilage patterns across the whole system, distribution centers, regional flows, seasonality, you name it. And to handle all that data, potentially millions and millions of sensor readings, they need powerful math engines. They're trained on that same stream of real-time sensor data, often using advanced machine learning frameworks. Things like PyTorch, designed for this kind of time series analysis. This helps the models learn the subtle rhythms of the supply chain that old forecasting methods would just completely miss.
You mentioned specific platforms like PyTorch. For someone not deep in the tech side, why does that matter? Why not just use, spreadsheets?
Well, it matters because it is about continuous learning. These advanced platforms let the models constantly take in new data, historical sales, weather, holidays, spoilage records. And they constantly recalibrate their predictions based on that new info. So the system learns from every transaction, every failure. It gets smarter week by week, improving inventory optimization, supply chain management. It's dynamic. It moves beyond just spotting today's problem to actually adjusting, ordering, and stocking to prevent future problems system-wide.
Okay, so the system predicts, let's say, a batch of milk is likely to spoil in 2 days, maybe because of that temperature issue last week. What happens next? Operationally, you've got this prediction the item needs to sell now. This must be where optimization comes in.
Exactly. This is where these intelligent systems, or you could call them co-pilots, really show their value. Once spoilage is predicted, the AI switches gears from passive prediction to active intervention. These co-pilots don't just send an alert. They actually suggest and can even implement dynamic promotions, time-sensitive discounts. And the goal isn't just, saving food for the sake of it, although that's good. It's about stimulating sales for those specific items flagged as nearing their end. The AI might instantly trigger a price drop. You might see it on a digital shelf tag. That digital tag changing the price on your yogurt, That's likely driven by an AI copilot flagging it has maybe less than 48 hours of peak freshness left.
Okay, sounds great in theory. But let's be a bit skeptical here for the audience. Putting in all these sensors, these AI platforms, that sounds expensive. If the AI is just discounting stuff, isn't the retailer just losing money differently? Where's the actual ROI?
That's a really important question. And the ROI is pretty immediate, and it hits on multiple levels. First, a markdown, even a big one, is nearly always better than a total loss, right? 100% write-off. So the recovering revenue that would just been thrown out. Second, these systems help optimize staffing. You don't need as many people manually checking dates and sticking on discount labels. The pricing is automatic. And third, it improves the customer experience. People get lower prices on fresh food. That builds loyalty, drives traffic. So it really becomes a win-win. Good for the bottom line, good for sustainability, and good for the customer.
Right. Turning a guaranteed loss into some recovered profit and a customer deal? Smart loop. Okay, let's shift focus a bit. Moving from inside the store or the warehouse to the whole journey. From farm to shelf. Why is that complete, unbroken traceability so critical for this whole thing to work?
Because with perishables, trust and verification are absolutely everything, especially when health and safety are involved. Traditional paper trails or, separate company databases, they just don't provide the level of certainty needed. This is where blockchain plays a really crucial, non-negotiable role in the modern supply chain. Blockchain boosts traceability and transparency because it fundamentally changes how data is recorded and stored. Instead of one company holding a central record they control and could potentially change blockchain, creates immutable records.
Immutable records.
Yeah.
Okay. Give us an analogy. What does that mean practically?
Okay, think of it like this. With a normal database, if I log the temperature of a pallet, I can maybe log back in later and change that number, right? To hide a mistake during shipping, perhaps. With blockchain, that temperature reading gets time-stamped, cryptographically secured, and then shared across a network. The farmer, the shipper, the distributor, they all have a copy. Changing the record on my server doesn't change the copies everyone else holds. To cheat the system, you'd have to somehow convince multiple independent parties to all agree to rewrite the past at the same time. It's virtually impossible. So this level of verifiable transparency ensures the goods met safety standards, stayed fresh, were handled properly at every single point.
Ah, okay. So if there's a big recall, say, some contamination scare with spinach, they don't waste days digging through paperwork from 5 different companies. They can instantly see exactly where that batch came from and which specific stores it ended up in.
Exactly. And the value there is twofold. First, it dramatically speeds up compliance with regulations, especially food safety. That reduces risk and liability. And second, that kind of radical transparency just naturally builds consumer trust. If a retailer can actually prove a product stayed in the perfect cold chain its entire journey, that builds huge confidence, huge brand value.
That definitely connects the tech back to the customer and to the C-suite. That's where things get really interesting and strategically. Now, let's talk impact numbers for the listener trying to wrap their head around the scale of this. What are the big so what metrics?
The numbers are really compelling based on those industry studies you sent over. We're talking massive economic drivers here. AI adoption, specifically in waste management. It's a forecast to potentially save retailers globally up to $10 billion a year.
$10 billion annually.
Annually. That's the kind of incentive that drives rapid change. It's basically a huge financial win hiding inside a sustainability initiative. And what's more, the early pilot programs, where they actually put these systems together, the sensors, MCP, the co-pilots, they've successfully cut overall food waste by about 15% in those controlled settings. So it shows the tech isn't just theory. It delivers real results, helps meet climate goals, and boosts the bottom line.
15% reduction just in early pilots. That's a massive start. But it brings up a key question, one I bet listeners are thinking. If the savings are that big and the tech works, why isn't every single retailer doing this already? Like right now. What are the hurdles?
Yeah, there are 2 really significant obstacles, and they both kind of boil down to infrastructure. The first big one is just the sheer amount of data involved and upgrading the existing tech. You need a really robust data infrastructure to collect, standardize, analyze all that sensor data, and crucially do it in real time across thousands of products and locations. Most big retailers are running on legacy systems. Older IT setups, often siloed, that just weren't built for this constant flood of data from millions of little IoT sensors on trucks, fridges, pallets. Upgrading all that, putting sensors everywhere, making sure the data flows cleanly so the AI can actually use it, that's a massive, complex, and very expensive job.
Right. So it's not just buying the fancy AI software, it's like ripping out all the old plumbing and putting in a whole new data superhighway under the entire operation.
Exactly that. You can't run a Formula One car on bumpy country roads. You need the right foundation. The second major challenge is around regulation and compliance. These AI solutions have to be carefully aligned with existing, sometimes pretty rigid regulatory frameworks. You have to ensure they consistently meet all the safety, quality, and compliance standards.
Yeah, I can see the friction there. If an AI copilot automatically discounts something that's safe but just near its date, how do regulators make sure the retailer isn't, subtly using the AI to push food that might be slightly borderline?
It raises complex questions about accountability, definitely. If an algorithm sets a price based on a calculated spoilage risk, regulators need to understand how that decision was made. And they need to be sure the algorithm isn't prioritizing profit over, say, public health. So it requires careful, transparent implementation and ongoing monitoring, making sure the AI sticks to quality standards, not just inventory goals.
It really sounds like the tech itself is pretty much ready to go, but getting the data foundation right and navigating the regulatory side, those are the big things, slowing down universal adoption.
Okay, so what does all this mean for you, the listener, trying to synthesize this whole landscape? We've seen how predictive analytics, MCP, blockchain, they're pushing the whole food retail sector away from just reacting to waste, moving towards a future that's much more sustainable, much more efficient operationally. They're basically taking the guesswork out of freshness.
Exactly. And looking ahead, the next step is making these co-pilots even smarter. Your sources suggest that this next level of sophistication will offer much deeper insights, not just about the product's life, but about consumer behavior too, purchasing patterns. The retailer is getting this incredibly detailed view of the life cycle of every single thing they sell. And that's where it gets really fascinating. Here's a final thought for you to consider. If AI can already predict exactly when a carton of milk will spoil because of a tiny temperature blip weeks ago, how might retailers use that same level of deep insight to predict when, where, and why you will decide to buy that milk in the first place? And maybe even what else you'll want to buy with it. That convergence, predicting inventory and predicting consumer demand with that kind of precision, that seems like the real holy grail for the next wave of retail tech.